So we're going to continue. Okay. So this is the way it works, right? You have the formulations. You have to be careful because the exponential changes rapidly. You go up and then you start going down. Okay, and that's you have to be careful when you use Excel or any other calculator to evaluate this function. Very careful. Here, I have another figure. You have it in your class notes about the how do we obtain, what do we obtain when we change the C state? Okay, for example, here, I have 3 states. I employ only the formulation from Pearson-Moskowitz. One is, the green is with 30 knots, the red is with 25, and the blue with 20. Anything that calls your attention, Miss Vega? Miss Vega, is there anything interesting for you in this graph?
So I can see that depend of the velocity of the wind.
Yeah, but anything else? I mean, you're telling me that they are different. Yeah, they are different, but come on, you should see something else. Be something different.
Yes. So the amplitude is more.
Yeah. Oh, yeah. That's important. That means that if the wind is higher, the area below here is going to be higher. Definitely. That's something which is very important. Anything else, Mrs. Lobo? Anything else that calls your attention from this graph?
Well, the value, the highest value, when you increase the wind velocity, it's going to the left.
Yes. So that means that the largest energy, you have it with at the lower frequency harmonic. That means that the largest energy, you're going to have it at a wave which is longer. So, for example, if we have, for the blue, we have something like this. Okay. For the green, we're going to have something higher amplitude, and it's going to be longer waves. Okay. That means that, remember that when we have shift dynamics, the frequency can correspond to the natural frequency of the waves, could be natural frequency of the ship, and we're going to have resonance. Okay, so if we have one of these states which adds a lot of energy around a frequency which gets closer to one of the natural frequencies, you're going to have resonance. Even though there is no, this is not a regular wave system. But the thing is that there is a lot of energy. The largest energy is in an area of frequency which are close to. Okay, so that's something which has to be very interesting. Okay, yeah, and remember that the area under the curves corresponds to RMS squared. Okay, RMS squared. Okay, so that's something that we have to remember. Okay, so this area here corresponds to R at 0, is RMS squared. And it's equal to sigma squared for 0 mean. So immediately we see that when we have 30 knots, the area is much larger than under the green and the red than under the blue. Okay. Okay, people, is there any questions about this? Okay, so right now, show can you see assignment? Okay, so we can go on and let's see, Miss Astudillo, would you please read number 5, exercise number 5?
Yes, doctor. Using Pearson-Moscovitz and ETTC formulation, calculate the spectral density of the sea elevation for state 4 using information taken from point 4.
Okay, so you search, find a table, look for sea state 4. That will give you, in the case of the Pearson-Moscovitz, the wind velocity. In the case of the ITTC formulations, you need the significant height and mean frequency of zero up crossing. With those 3 parameters, you can develop these functions. Okay, that's what I'm asking the first time. Go on, Miss Astudillo.
Integrate the area below these curves and estimate the mean square.
Okay, so remember that's the mean Wiener-King-Chain relations. Okay, R at 0 is equal to S d omega integrated. So that's the area under the curve. So you integrate that. And the integration is equal to R sub 0, and R sub 0 is equal to mean square. The RMS is presented in the formulation. Go on, Ms. Astudillo.
Compare these results with the one specified in the table from 4.
Okay, so they present the RMS. So you compare these values, the curve, the area under the curve, square root of that with the significant height. No, with the, I'm sorry, with RMS value. Okay, so in this way you can practice these formulations from the spectral density. Is there any question, people? Any questions?
For what day we have to submit this homework?
On Tuesday. Oh, I have to change that. Thank you. Then let me write down that. So it's going to be Tuesday at 4 p.m. Okay, thank you. Thank you very much. Any other question, people?
Doctor, I have a question. Today the class is intro to the quiz.
Yeah.
Okay.
Yes. I have a problem because I don't like to have evaluations online. So that's my main problem. The next evaluation, I want it to be in person. So you decide the day that you have to come to the university. It has to be in person. I don't want to take evaluations online anymore. So you get together, if you want today, decide when you want to take it, and on that day, I will give it to you. Has to be next week. Okay, people, did you hear me?
Doctor,
what
day is the lab? Sorry. What is the day of the lab?
The last day of classes. The last day of classes, according to me, maybe
No,
I'm wrong.
laboratory class.
Oh, lab class. Tomorrow we have agreed with Andy to come to the university and try to make it work. Okay, we're going to be working on that. And I think it's a very good experience. See, after we got the shaker, and the shaker provides random signals, we start working with these random processes, and it's very interesting. We have learned a lot. So I would like you to have at least one experience in working with a random signal, and you've seen it. See, it's not that I can give you a random signal, and you're going to provide one, produce one using the exercise one, but it's different if you measure. So I need to do that. Yeah. If we can make it work tomorrow, yeah, we could agree for next week or something. What you're suggesting is on that day, maybe we can do two things. Yes, that's a good suggestion, Miss Astudillo. Good point. Yeah, but that's up to you. I don't want to give you online quizzes anymore. Definitely. Or you decide. Any other question, people? Ms. Freire, what do you say? When would you like to have the evaluation? In person? Never.
You said when?
Yeah, when?
Is it possible the same day of the lab class?
That's a good suggestion. What we could do is this. Let's try to do it next Thursday. Okay, let's try. If we can do it next Thursday, we'll be okay. Okay, so on Tuesday, I will have a final word about that. I don't think it's that difficult. Maybe we missed one parameter or something in the configuration of the shaker, and we couldn't make it work this morning. And hopefully we will be able to solve it tomorrow. So yeah, that's a good proposition. So at the very beginning, what I would suggest is that on Thursday, next Thursday, we could do what first? Lab or quiz? Quiz first. Okay, so we go quiz from say 1 to 2:30, and from 2:30 to 4, we will go lab. How about that? Okay. I would like to see an answer. Come on, people.
What was the time?
You can start at, this is just a suggestion. I'm not, you have to, at the end, eventually we have to agree. But since we have to do two things, okay, I would go for, let's start at 1. From 1 to 2:30, that would be the evaluation. Closed book, multiple choice, small questions, one problem probably. I don't know, I haven't even started thinking about you. And in the second part, we will do the experiment. So we will get a signal generated by the shaker, a wave elevation, and the response of the model. And then we will see that there is a relationship that we're going to deduce this coming Tuesday between the RAW that you already calculated with the spectral density of the incoming waves and the spectral density, spectral density of the response. That's the roll motion. Did I answer your concern, the person who asked me?
Yes.
Ms. Lopez, what can you say? You agree with that? Ms. Lopez, are you there?
Yes, doctor.
We say in Spanish, el que no habla, otorga. El que calla, otorga. So if you don't say anything, that means that you are saying, I'm okay.
I am okay.
Okay, good. Okay, people. So I'll let you work. I'll let you decide. And that's a good proposal, Miss Ashley. That's a good one. Okay, so our plan is this, okay? Next Tuesday, people, next Tuesday, I want everybody to describe the ship that you are going to analyze. Minutes presentation. I want everybody to participate. Main dimensions, main characteristics. It's possible that somewhere somebody specified the C state that you have to consider. It's possible that, for example, you start worrying about certain parameters. For example, in the case of passenger ships, of course, the problem is always MSI. We're going to define that. That means that the possibility that the passengers start throwing up. Okay. In some other cases, it's another parameter. So that's a good idea if you have read or have or the owner specified that or anything like that. So 2 minutes for each one, each group, because that's a lot of groups here. Questions?
Doctor, for that presentation, we have to do a PowerPoint or something like that?
Yeah, definitely PowerPoint.
Okay.
That helps a lot. So please, 2 minutes per group. That's all. So all I want is to start thinking about the project. Yeah, because by experience, we always say, yeah, I'm working. Yeah, but show it to me. That's what I want to see. So main characteristics, description of the ship, loading conditions that you are going to analyze. It's possible that you have read, you have seen, or the ship owner has specified the sea state conditions. What parameter is he worried about? Those information in 2 minutes, each group. Especially, I would like for you to organize so that if you get 3 minutes and you are a group of 3, yeah, you should have at least 40 seconds for each one. So everybody should participate. I need you to practice your English. Questions, people? Questions. Okay, in that case, Mr. Zamora, thank you very much. You can stop the recording. Please send me those two